Hello everyone, welcome to today's session. In today's session, we are going to start chapter. The name of the chapter is Applications of Trigonometry. And as far as the importance of this chapter is concerned, there are two important things that you need to keep a note of. The first thing is what's the board weightage of this chapter? So the board weightage is 6 marks. You can expect two questions from this chapter in your class 10 board examination. And as far as Olympiad examination is concerned, competitive examination is concerned, you can expect 1 to 2 questions from this particular chapter. Okay. You can expect 3 also, maybe, but yeah, generally you will see 1 to 2 questions only from this particular chapter in your competitive examination. Okay. So the board weightage is 6 marks. The competitive examination weightages, you can see around 1 to 2 questions from this particular chapter. And believe me, this is one of the most interesting chapter. And we are going to see the significance or like why we studied our previous chapter, that is Introduction to Trigonometry. Here you will see the application in the real life of all the things that you studied over there. So I think we should start this topic. So the topics that we are going to cover in this particular lecture, there are 3 topics we are going to cover. The first one is angle of elevation. That is going to be our first topic. Like what is the meaning of angle of elevation, right? The second topic that we are going to cover is angle of depression. You will frequently come across these two terms whenever you will be doing the problems from this particular chapter. The third topic that we are going to cover is application problems on tree building, etc. Means we are going to cover some specific type of problems from this particular chapter. And in this lecture, we will cover problems related to trees. We will cover problems related to buildings. So whenever I will explain anything to you, be it topic, be it application, be it anything, you like remain attentive, and wherever you feel you haven't understood, let me know. I will rediscuss that particular thing. Okay, so don't feel hesitate. That's what I want to say. So I think we should start our chapter, topic number 1, which is angle of elevation. It's super easy. Okay, see, if you even go to dictionary and check what is the meaning of this word elevation, then you will see that the dictionary meaning of this word elevation is actually height. Okay. And here the topic that we are discussing is angle of elevation. That means angle that is in some way related to height of any particular object. That object might be tree, that object might be building, that object might be anything. Okay. But yes, we are taking into consideration the height of the object which is under consideration. Okay, which we are discussing here. So let us quickly go through the statement, and then I will tell you what is the meaning of that in this figure as well. It says when you see an object above you, what's the meaning of this? Let's say this is the position of yours. Okay, this is your position. Okay, and you are seeing an object above you, and there is a boy who is standing at the top of this tower. All right. And this girl that is standing here at the base, she observed this boy that is this boy who is standing on the top of the tower. Then this is the direction in which she is going to see the boy who is at the top, right or not? Then this line that is formed, this line that is formed here, this line is referred to as line of sight. Always remember this. Okay. And if I draw one perpendicular from this boy, okay, the object we are observing from the base, right? And if I join that base of the perpendicular drawn to the object, okay, from where we were observing the second person, then this line is called horizontal. Remember this. And this angle which is formed here, theta, that is going to be referred to as angle of elevation. Angle of elevation. Like if you read this statement which is given here, it says the exact same thing. When you see an object above you, it is very important that when we are talking about angle of elevation, the object we are observing, that should be at a position which is above you. That should not be at the position below you. That is first thing which you need to keep in mind. There is an angle of elevation between the horizontal. If you read, between the horizontal and your line of sight to the object. That's what we are saying, guys. Let me take one more example to explain this to you. Let's say this is my position. Okay, this is the position of object. All right, and here we have a bird. We have a bird at any instant. Let's say this is a bird. Okay, we have a bird at any instant. All right, so if this is the position of any boy who is standing at the bottom or at the ground, and the boy observes the bird, then this is the direction along which the boy is going to observe that particular bird. True or not? Right? And if I draw one perpendicular from this bird to base, all right, and if I join that base, that bottom of the perpendicular which is drawn to this boy, all right, then this line that I got here, this line will be referred to as line of sight. Remember this. Okay, this is going to be referred to as height or perpendicular or whatever you are going to call it as per the situation which is given to us, and this is referred to as horizontal. All right, and always remember that this angle, I'm going to denote it by alpha. This angle alpha, it will denote here angle of elevation. Okay, it will denote here angle of elevation. Is that clear to everyone? What is the meaning of angle of elevation? Angle of elevation, like whenever you are talking about angle of elevation, it is very important to keep in mind that the object or bird or whatever we are observing, the position of that thing should be above you, and the direction to which it observe, like the line along which you observe that particular object, is called line of sight, that I discussed just now, right? And the angle which is formed between the line of sight and the horizontal, this particular angle is referred to as angle of elevation. And these are just the symbol that we use to denote angles. This symbol is called alpha. Okay, it's a Greek letter. This symbol is called beta. Okay, this symbol is called gamma. This symbol is called gamma. Okay, this symbol is called theta. Understood? Like these are the symbols that we are going to use to denote the angles that we are going to discuss or that we are going to take in the different situations. You can go through it. If you still feel you have any doubt, feel free to ask me before I tell you how you have to apply whatever you read in your last chapter here to solve the real life problems. All right, you can go through it before we move ahead. Is it done? All right, check out. Now we have an application of this, guys. It's super easy. We will decode this problem step by step first. Let us read this problem and highlight whatever is important here. It says if the angle of inclination, okay, or angle of elevation found by an observer to an object kept above a tower is 45 degree. What does that mean, guys? That means this angle that we have, like I hope you all can see this figure. That means this angle that we have here, this is 45 degree. Understood? Then what are they asking us? They are asking us find the horizontal distance between the observer. This is the position of observer. Okay. And the base of a tower if the height of the tower is 150 feet. Okay. This is the base of the tower. So I am going to name the tower as well as object. Let's say this object is denoted by A. B is the top of tower. C is the base of tower. So this A, it denotes the position of any object. Okay. And this B, that represents the top of the tower. The C represents the base of the tower, nothing else. Okay. And what do we have to calculate here? We have to find out AC and what are we provided. I am writing what all are we provided and what we have to calculate. We are provided height of the tower. Height of the tower means you are provided BC and the value of BC is nothing but 150 feet. Okay. The angle, the second thing which you are provided is angle of elevation, which is angle BAC, and that is 45 degree. All right. And what do you have to find out? You have to find out the distance between, if you read this, you have to find out distance between observer and base of tower. That means you have to calculate AC. So that is again very easy to calculate, and how you can calculate it, check out. See, you know this angle, right? And if I consider this angle, then the side which is opposite to this angle will be considered as perpendicular or height. So this is height that we have, and this side will be referred to as base. Now we know two trigonometric ratios which include perpendicular and base. One of them is 10 and the other one is cot. So you can use any one of them, okay? But generally we prefer to use 10 because we are so much used to it. So you have to basically use a trigonometric ratio which involves perpendicular and which involve base. So you have got two options. Either you can use 10 or you can use cot. And here I'm going to use 10. But whatever you use, the answer is always going to be same. Okay. So in triangle that I have, in triangle BAC, clear? In this triangle BAC, what do we have? In this triangle BAC, if I calculate 10 of 45 degree, what will I get? 10 of 45 degree is going to give me perpendicular by base. That means I am going to have BC over AC. Clear? We all know the value of 10 45, which is 1. BC, we are already provided 150. And AC, we have to calculate, right? So if you solve it further, what will you get? You will get AC is equal to 150 feet. And that's exactly what we were supposed to find out here in this problem. They were asking us what is the distance between the observer, which is denoted by A here, and the base of the tower, which is denoted by C. So here AC we got is 150. I hope you all understood it. You can go through this entire solution once again before we move ahead and discuss the next thing that we have. Okay, please go through it. All right, understood. All right, let's move ahead. You can, like, this solution has been given, guys, for your reference. If you want to go through it, you can certainly go through it. They have also done this problem in exact same way. Let me highlight. Theta was given to be 45 degree. Height of tower was provided, which was 150 feet. And we were supposed to find out the distance between the observer and the base of tower. So they did the exact same thing. 1045 is going to be 150 over D. We know that 1045 is 1. Therefore, if you substitute the value and you solve it, the distance, the required value you are going to get is 150 feet. And that's your answer to this problem. Understood? Okay. Now, what is the second thing we have? The second thing we have is angle of depression. Okay. Even if you look at the dictionary meaning of this word depression, depression is, let's say, this is the surface where I am standing. Then if I'm talking about depression, then that means a surface which is below this surface. That means if this is my surface, then this surface which I have here will be referred to as, like if I take any point on this surface, then that will be referred to as a point which is in the depression. Understood? So that means when you have an object below you, as mentioned in this definition, when you have an object below you, then there is an angle of depression between the horizontal and your line of sight to the object. It's very clear, right? You see this figure. Let's say there is a person who is standing, right? And he observes a dog at this position. Okay. Then this line will be referred to as line of sight. Let me highlight this. This line will be referred to as line of sight. Understood? This will be called as line of sight. Here, this will be referred to as line of sight if the person is observing aeroplane. correct? Then this angle that we have here, okay, I'm going to denote it by alpha and this one is beta. Then this line is called horizontal. This angle that we have, because this angle is formed between the object, between the observer and the object which is lying below it. Okay, then this angle which I have denoted by beta here will be referred to as angle of depression. Okay, this angle that we have denoted by beta will be called as angle of depression, while the another angle which I have denoted by alpha is called angle of elevation. Remember this. Okay, so more or less the concept of angle of depression is very similar to the concept of angle of elevation. Is just that when we are talking about angle of elevation, the object which we are observing, that should be above the position where I am standing, and when we are talking about angle of depression, then the position of the object under consideration must be below it. That is the only difference. Apart from that, be it horizontal, be it line of distance, everything else remains same. That's it. Okay. Is it clear? The meaning of angle of depression? Depression means below and elevation means above. I am writing it for your significance. Elevation means what? Above. Okay, remember this. And depression means you are talking about below. Okay, depression means below. That's it. All right, please note it. Okay, let's see. Now what do we have? The angle of depression of a stone. This is an application of what we studied just now. The angle of depression of a stone from the top of the tower on the ground is 45-degree. Okay, this is the top of the tower. This is the stone that we have. Let me write it here. Okay. This is the position of a stone. All right, that represents top of tower. That represents top of tower. Okay, if the stone is away from the building at a distance of 120 meter, that means this is the bottom of the building, right? This is the bottom of building or tower, whatever you want to say. Okay, and the stone that we are considering here, the distance of that stone from the bottom of this tower is 120 meter, and the angle of depression is given 45-degree. All right, now this line that we have here, it will be referred to as horizontal. We all know that. Okay, as well as this line will also be acting as a horizontal. Clear? Now, because these two lines will be parallel, as this angle will be 90-degree, that angle will be 90-degree. Therefore, this angle that you got here, which is equals to 45-degree, will be same as this angle, because these two angles will be alternate interior angle, right or not? And what do we have to calculate here? You have to find height of tower. Okay, so basically you have to calculate PQ, which represents height of tower. All right, so check out how we can do it. So what we can do is we can assume height of tower to be h. Let height of tower be h. Okay, so if height of the tower is h, right, that means I have to find out h. Now what do we have? Because this angle that you have, angle SPR, which denotes the angle of depression, that would be same as angle PRQ, right? And both of them will be equal to 45-degree h, 45-degree each, alternate interior angles, right? So now what I can do is I can apply the concept of trigonometry in triangle PQR. And if I calculate tan of 45-degree in this triangle, what will I get? Tan of 45 degrees perpendicular by base. So that is going to give me PQ upon base, which is QR. Understood? Tan 45 is 1. What is PQ? I don't know, that I have to calculate. What is QR? QR is provided to me. That's 120 meter in the problem itself. So what is the value of H I got? The value of h I got is 120 meter. And you have to be very careful when you write your answer, final answer. Please do not forget to mention unit, because if you will not write unit, there are chances that you might lose some marks because of that. So don't ever do that. So the height that you have of the tower here in this problem, that is going to be 120 meter. And that's what, like, that's how you have to do it. And that's what the meaning of angle of elevation and angle of depression is. See, and one important thing, that thing is, till now, like, we did two problems. In one of the problem, we applied the concept of angle of elevation. We, in the second problem, we applied the concept of angle of depression. But in the upcoming problems, there is a possibility that we might have to use both. Okay, means the problems that we are going to see now, they might be more complex in nature than the problems that we have done just now. All right, please go through this solution. Ask me if you haven't understood anything. I will be more than happy to explain it. I'm going to give you 30 seconds for that. Done? All right. So, like, this solution is for your reference, guys. You can go through it if you want to go through it. This actually gives you an idea of how you have to actually represent your solution in your board examination, so that you don't lose even single marks. That's it. Okay. Concept wise, you all know like how to do it, but how to represent it, that's very important as far as board examination is concerned. So keep this way of representing the solution in your board examination always in mind. Okay. So now we are going to do few problems based on tree, buildings, etc. Okay. And it's just that you have to be good when it comes to decoding the problems or the language that we are provided in the problem. If you are able to do that, believe me, the problems are super easy. For example, let's discuss this problem. What does it says? It says from a point on the ground, so that point is P here. I'm highlighting that. The angle of elevation of the bottom and the top of a tower fixed at the top of a 30-meter high building are 45-degree and 60-degree respectively. So this is the point. This is the tower we have. Let me mention it. Okay. This is the tower that we are talking about here. And the angle of elevation of the bottom and the top of this tower. So this is the bottom of tower. Okay. This is bottom of tower, and that is top of tower. All right. That is top of tower. Okay. So this information we are provided, the angle of elevation are 45 and 60-degree each. If this is given to you, you have to find out the height of tower. So basically we have to calculate the CA. All right. And the value of root 3 which you have to use is 1.732. Let's see how we can do it. Check out. So I'm going to assume height of tower to be h. That means I'm going to assume CA to be h. Okay. And I'm going to assume, okay, we are already provided height of the building. So I have assumed CA to be h, which represent height of tower. 1 second. It represent height of tower. Okay. And what are we given? We are given AB, which represents height of building that we are given. All right. And I'm going to assume let BP be X, or all right. So we have two right triangle here, guys. Okay. So if I consider this triangle in triangle ABP, the smaller right triangle that we have, if I calculate 10 of 45-degree, what will I get? We know that 10 theta is given by perpendicular upon base. So 10 of 45-degree is going to give me AB upon BP, because AB represents perpendicular, BP represents base. 10 45, we all know that's 1. AB is given to be 30. BP we don't know. So the value of BP we can certainly calculate from here. So what will be BP? BP is going to be 30 meter. Understood? Like this is the distance that we got of the observer from the base of the building, right? Now we are going to use this result further. Let's see how. We have one more right triangle. So if I consider this triangle, in triangle CBP, so in triangle CBP, if I calculate 10 of 60 degree, what will I get? I'll get perpendicular by base, and here perpendicular is going to be CB, base we have is BP. Okay, what is 1060? 1060 is root 3. We all know that. What is CB? CB is a sum of CA plus AB, right, divided by BP, which is given by 30 meter from here. If you cross multiply, what will you get? You will get 30 root 3. That's equal to what? CA plus AB, right? CA is H, AB is 30. Clear? Now, what we can do, we have to find out H. So we can transpose this 30 that you have here. We can transpose this 30 that you have here on the left hand side. So what will you get? You will get H is equal to, you will get H is equal to 30 root 3 minus 30 meter. Okay, that's what you will get. You can take 30 common. If you take 30 common, you will get root 3 minus 1 meter inside the bracket, right? What is root 3 that you have to use? The value of root 3 which you have to use is 1.732. So I'm going to put it here. So I'll be getting H is equal to 30 multiplied to 1.732 minus 1 meter. So I'll be getting 30 into 0.732 meter. And I can remove this decimal. I'll get 1000. This 0 will cancel this 0. Now I can multiply 3 to 732. So I'll be getting 3 into 2, that's 6. 3 into 3 is 9. 3 into 7 is 21 over 100. So what is the value of H I'm getting here? The value of H is 21.96 meter. And this H which I got here, what does it represent? It represents the height of tower, which we were asked to find out in this problem. I hope it is clear to everyone. It's just that in this problem, we were having two right triangles, and we have to relate the results that we are going to get in one of the right triangle to the results that we will be getting in the other right triangle. If you do that thing along with the calculation correctly, there is no one who can stop you from getting correct answer. All right. So you can check it, go through it before we move to the next problem. All right, shall we move? Okay, you can check this as well. And here the solution has been provided for your reference, guys. They have done it in the exact same way, and you can observe the answer that we got finally. That is exactly same. Hence the height of tower is 21.96 meter. Like they also like considered both right triangles. They applied the trigonometry in both the triangles, simplified. Okay, then they called this result as first result. Then they applied, or they used 10 the formula for 10 theta in the other triangle. They got second result. They related both the result, and after relating both the result and doing the calculation perfectly, they got what they were supposed to go, what they were supposed to get. That's the answer to this problem. All right. Okay. Now what do we have? Okay, we have this problem. This is a good problem, no doubt. And be very careful when you read it. What does it say? It says two trees are standing on ground. So you can observe this figure. This is one of the tree. This is the second tree. First tree is denoted by AB. The second tree is denoted by CD for the sake of simplicity. Okay. The angle of elevation of the top of both the trees from a point X on the ground is 40 degrees. So this is the angle of elevation. That's 40 degree. And this is the point under consideration, which is denoted by X. If the horizontal distance between X and the top and the smaller tree is 8 meter, and the smaller tree is 8 meter. So you can see if the horizontal distance between x and the smaller distance is 8 meters. So they are talking about cx or xc, which is 8 meter. I have highlighted that. And the distance of the top of the two trees is 20 meter. That means this distance, which is denoted by BD, is given by 20 meter. Then you have to calculate the distance between the point x, okay, and the top of a smaller tree. That's first part. Let me write, okay, to find. What do we have to find? Okay, so you have to find xd first, okay, that's your first thing. What's the second thing? You have to find the horizontal distance between the two trees. That means you have to calculate AC. So these are the two things we have to calculate. And here, one important thing I would like to highlight, because the angle of elevation we are provided is 40 degree, and in 10th standard, we haven't come across the trigonometric ratios of angle 40 degree. So in case you come across any problem whose, let's say, you haven't studied the trigonometric ratios of that particular angle, so to ease out that, they will always provide you the they will always provide you the needed support, you can say. For example, here they have given you the value of cos 40. Okay, if you know cos 40, if needed you can calculate sin 40. If needed, you can easily calculate tan 40. So basically this cos 40 can give rise to two more values. So whenever you will come across situation like this, they will always provide you the values, the trigonometric ratio of the value, which you can use to solve out this problem. So here we are going to use this cos of 40 degree that we are provided. Okay, so let's see how we can use it. Okay, check out. All right, so I'm going to consider first, like we have two right triangle here. If you see this figure, one of the right triangle is ABX, which is bigger right triangle. The other one is CDX. So I'm going to use trigonometry in both the situations or both the triangles. So first case, if I consider triangle CDX, then in this triangle CDX, if I calculate cos of 40 degree, we all know what is the formula for cos theta. That's base by hypotenuse. So base is cx. Okay, what's hypotenuse? Hypotenuse is xd, which we have to calculate, right? What is cos 40? That is 0.7660, which you can easily see on your screen. Okay, that is 0.7660. Okay, what is cx? Cx we have to, okay, Cx is given, which is equal to 8, right? And what is xd? Xd is, we have to calculate, okay? So we know that cos of theta is given by base upon hypotenuse. So for in this triangle, if you are calculating cos 40 degree, base is going to be Cx, which I have written. Hypotenuse is the longest side of the right triangle, that is xd. I substituted the value of cos 40, which is 0.7660. Then I substituted the value of Cx, which is 8. Okay. Now I have to solve it to get the answer. So what is xd? Xd is going to be 8 over 0.7660. I can remove this decimal. So I will have 4 zeros in the numerator. This and this will get cancelled. So what will I have? I will have xd is equal to 8,000 upon 766. You all are requested to quickly solve it and let me know what you are going to get if you divide 8,000 by 766. Quickly do it. The answer will be very close to 10, of course. Okay. Yes, it is going to be 10.44 or maybe 10.45 if you want to call it approximately. Okay, so the value of xd which you will get approximately, that would be 10.44 meter. Okay, so that's the answer to the part 1 of this problem. That is the distance, that is the distance between the point x and the top of the smaller tree. That distance here is 10.44 meter. You will not say 10.44. That is incorrect way of saying it. You are going to pronounce it, or you are going to call it 10.44 meter. Is that clear? All right. Now, what is the second part? In the second part, we have to calculate AC. So to calculate AC, I have to, of course, move to the bigger triangle, which is ABX. So check out here. Second part. In triangle ABX. So in triangle ABS, X, if I calculate cos 40 degree, what will be cos 40 degree? That is going to be cos 40 degree will be equals to what? That will be equals to BX. Okay, sorry. AX, which is base upon hypotenuse BX. So you will have AX upon BX. You will have AX upon BX. Okay. Cos 40, we all know that is 0.7660. All right. What is AX? AX, if you observe, that is AC plus CX. AX is AC plus CX. So we can write it here. AX is AC plus CX. And what is BX? BX is BD plus DX. BX is BD plus DX. All right. So now we are going to substitute the value. We have 0.7660. That's equal to AC plus CX. So what is AC? AC we have to calculate. CX is 8. So you will have AC plus 8. You will have AC plus 8. AC plus 8. 1 second. AC plus 8. Okay. In the denominator, you have BD plus DX. So BD plus DX, because meter, you can see, and dx we calculated, which is approximately 10.44. Okay, so 20 plus 10.44, you will have 20 plus 10.44. Okay, so what will you get? You will get 0.7660 multiplied by 20 plus 10.44, that will be 30.44. Okay, and that's equal to AC plus 8. Guys, quickly multiply 0.7660 and 30.44 and let me know what you are getting. You can tell me approximate value. That's absolutely fine. All right. So you are getting 23.31. All right. So this is approximately 23.31. And here you will have AC plus 8. All right. If you solve it further, what will you get? You will get AC is equal to 23.31 minus 8. 23.31 minus 8 is going to give you what? Because 15 plus 8 is 23. So it is going to give you 15.31 meter. So that is going to be the approximate value of like the second part. And here I would like to tell you one important thing, because students generally get confused in that thing. If after decimal there is a little variation in your value, for example, I'm getting 15.31 and let's say you are getting 15.40 or 15.33, something like that, then also like it will be considered correct only. But yes, there should not be any variation in the values which are before decimal point. That is the thing which you have to keep in mind. I hope it's clear to all of you how you have to do it and how we covered both the things. But yes, you have to be very, very careful while doing calculation. If you make mistakes in calculation, then only God can save you, right? You can go through this solution, guys, whenever you need to. You can see they have done in the exact same way. The answer is 10.44 of first part. The answer to the second point is 15.32, although we got 15.31, I think, but that is absolutely fine. This much variation will work. All right, so let's move ahead and see what do we have. We have one more problem, and this is an important problem. This is from NCERT only, chapter number 9. Okay, it says you have two ships. Two ships are sailing in the sea on either sides of a lighthouse. So this is a lighthouse, guys. Okay, this is lighthouse. Okay, This is lighthouse. The angle of elevation of the top of the lighthouse as observed from the ships are 30 and 45 degree. So this is one of the angle of elevation, which is 30. This is the second angle of elevation, which is 45 degree. If the lighthouse is 200-meter high, we are provided the height of lighthouse, which is 200-meter. You have to find out the distance between two ships. Okay. And root 3 you have to use is 1.732. So what do we have to find? We have to find, let me write, you have to actually find CD here. Okay. What is CD? CD is actually the distance between two ships. Distance between two ships. Okay. And we know that CD is actually a sum of CA and AD. So I can calculate CA, I can calculate AD, I can add both of them. And CAB and DAB both are right triangles. So that's an added advantage we have to check out. So in triangle CAB, if I use trigonometry or if I calculate 10 of 30, what will I get? 10 of 30 will be perpendicular upon base. So I will be getting AB upon AC, right? If I solve it further, 1030 is 1 by root 3, we all know. AB is 200, we are already provided. AC we have to calculate. So what's the value of AC I got? AC is equal to 200 root 3. We can substitute the value of root 3 later on in the final result. Okay. So the value of AC we got is 200 root 3 meter, and this value denotes the distance of one of the ship from the bottom of the from the lighthouse, in short, not bottom, from the lighthouse you can say. Okay. Similarly, I'm going to do in the other triangle, that is triangle ADB. So in triangle ADB, if I calculate 1045 degree, what will I get? I'll get perpendicular by base. So I will have AB by AD. Okay. 1045 is 1, AB is 200, AD I don't know. So what is the value of AD I got? AD is equal to 200 meter. Okay. What does this denotes? This denotes the distance of the second ship from the lighthouse. And we know that if we can add both the distance that we got, that you can see in the result number 1 and 2, we will easily get our answer. So I'm going to add both of them for the answer. So therefore, one second. Therefore, distance between two ships. Distance between two ships, that is, what's the distance? Distance between two ships means CD, which is equals to AC plus AD. Okay. CD. It is CD, which is equal to AC plus AD. What's the value we will get? We will get CD, that's equal to AC plus AD. AC, if you can see here, that is 200 root 3, and that the other value is 200. So I'm going to put the value. So that is 200 root 3 plus 200 meter. Okay. You can take 200 common, you will get root 3 plus 1, right? Root 3 is 1.732. You have 1.732 plus 1. So you will be getting 200 multiplied to 2.732. You can remove decimal. You will get 1000, right? These two zeros will cancel these two zeros. So if you multiply 2 to 2732, you will get 464, and here you will get 5 upon 10. So what's the value you will get? You will get 546.4 meter. So this value that we have got here, this gives us the required distance between the two ships under consideration. Is that clear? Because 2 into 2732 is going to give you 5464. All right. So that's a distance between the two ships under the consideration here. All right. So like that's what you have to do. All the problems that we did till now, you can observe they were not difficult at all. It's just that you should be able to decode what is given in the problem. Like you should be able to read the language of the problem properly, and that will come naturally with doing more and more problems. Apart from that, you have to look for the right triangles that are forming in the problem. And you have to look for that right triangle, especially which has the quantity which you have to find out. You have to like use the trigonometric result, relate the different outcomes that you are going to get, and you will 100% get your result. All right. So before we end, I would like to let us quickly discuss what we read. First, we read what is angle of elevation. Then we read what is angle of depression. We did problems based on both of them, like the basic problems, of course, but we did the problems based on them. Then we studied the problems based on trees, buildings, ships, etc. And we observed how we can use the trigonometric ratio and the concept of angle of elevation and depression to solve different problems. And that's it then from this session. If you still have any doubt, you can always reach out to your subject expert. Thank you so much for attending. Have a great day. I'll see you all in the next lecture. Bye bye.